practice problems for lesson 5. In this first problem, you're supposed to translate A, B, and C 4 units to the right and 1 unit up. And so, if you do that, what I like to do is I like to connect the points first. It's just easier for me to see an image translate than it is to see individual points translate. And so here A translated 4 units to the right, 1 unit up to A prime. B translated 4 units to the right, 1 unit up to B prime. And C translated 4 units to the right, 1 unit up to C prime. So this whole triangle altogether translates 4 units to the right and 1 unit up. So it forms a prism. So a prism is made of a translated copy of a base. So this red triangle is a base. The black triangle is a translated copy of that base. So now you have 2 bases. And you connect those bases, each of the corresponding sides, with parallelograms. If they're right angles, then they form rectangles. So the sides are parallelograms, and they can be rectangles if the angles are right angles. So those are translations. So the next image, you're supposed to reflect point D across the y-axis, point E across the y-axis, and point F across the y-axis. So when you think of reflections, you think of moving in a line that is perpendicular to the line of reflection. In other words, it forms a right angle. So D is going to move this way at a right angle to Y and on an equal distance on the other side. E is going to move this way, a right angle to Y, so it's perpendicular to Y, forms a right angle, moves an equal distance on the other side, and F likewise moves at a right angle to Y and an equal distance on the other side. And so I showed the distance from the original point to the line of reflection, which is Y, in blue. This is 1, 2, 3, 1, 2, 3, 4, 5, and 1, 2. And then the distance on the other side in pink. It has to be an equal distance. So it's 1, 2, 3, 1, 2, 3, 4, 5, and 1, 2. So D prime, E prime, and F prime. And I connected them with these orange lines. So those orange lines are lines that form a right angle with the line of reflection, or Y. So what we say is that the orange line is perpendicular to Y, or the line of reflection. So the word perpendicular means forming a right angle, 90 degrees. All right, these are rotations, a little bit harder to explain. So you're supposed to rotate the points on the blue triangle 90 degrees, and you're going to end up where the pink triangle is. So G is going to go to G prime, H to H prime, and I to I prime. So let's take these one at a time. And the first one I'm going to go into a little bit more detail than the rest of them. So to rotate, it's going to be I to I prime. All right, to rotate I 90 degrees, you're going to move I over to this quadrant. So what are you going to do? You're going to switch the order of the coordinates. So this is going to become -2, 3. But then you're going to change the sign of one of them. So if you want to move it over to this quadrant and you switch the order, let's do the counting first. So I'm going to count along the x-axis to get to this point, so 3 units. That means I'm going to count the same number of units when I rotate this on the y-axis. So this y value, which is going to be -3, becomes -3. So this x value switches to y, and it becomes a -3. So that's the change in sign. So I'm going to count down, switch the order, change sign of x. So I'm going to count down, rotate it around 90 degrees, count down 3 units. So I've moved the x value to the y position, and I've changed the sign. So now up here, the y position is -2, and over here it's going to remain -2. It's going to become the x value. So it's going to go -2 and 3. So you're going to end up down here. So -2, -3. Count x on the x-axis. Rotate, and you're going to keep the same sign of -2. So this is -2. So now you're going to count down this axis 3. So it's -3, and then count -2 this way. So you want to end up in the third quadrant, which is negative, negative. So notice you've changed the order. So this is 3, -2, so this is -2, and it was a +3, but then you have to change the sign of that y value to count down here, and also to end up here in quadrant number 3. So it's just a lot of little details to think about, but with practice it just becomes natural. You just are able to think through it and see what's going on. I'm going to show you how to do that in a few moments. All right, so that's I to I prime. It's a 90-degree angle, I to I prime. What about H to H prime? That's a little bit easier because H is on the x-axis. So if I rotate this 90 degrees up here, H is now going to be on the y-axis. So you switch the order, so it's going to become 0, -4, but then you have to change the sign of the -4 to +4. It's because you're going to count up 4 units. So this is 0, 4. A little bit hard to see here. Here it is right here. This is this red arrow from H to the origin, and then you move up to H prime up here. So it's a 90-degree rotation of H from here to here. And G to G prime. To get to G, you count in this direction 1 unit, -1, and up 3 units, the y value. So a 90-degree rotation, switch the order. So this is going to become 3, -1. So 3, and this was a -1, but you want to end up in this first quadrant. So you're going to change the sign of the y value to 1 unit. So now I'm going to count up 1 unit and then 3 in the direction of rotation along the x-axis. So this becomes 3 units and 1, or you can count 1 unit and 3 in this way if you want. If you want to count in the same order. Regardless, it moves this point G to this point G prime, which is a 90-degree rotation. So G to G prime. Now you can play around with this a little bit. I'm just going to use G as an example, and then I would suggest that you do the same thing with I, and then the same thing with H. I'm going to move G 90 degrees through this quadrant, 90 degrees at a time. So I'm going to move G to here, G to here, and G to, I'm going to call this G prime, this G double prime, and this G triple prime. I'm going to move it 90 degrees, 90 degrees, 90 degrees, and then return G to its original spot, 90 degrees. So now in every case, you're going to switch the order of the coordinates, and you're going to change one of the signs. Well, if I want to end up over here, what does the sign of both of these coordinates have to be? Well, quadrant number 1, both coordinates are positive. So I'm going to switch the order. So I'm going to move out this way 3 units along the x-axis and up 1 unit. So it's going to end up right here. So it's switching the order and changing the sign of one of them. Now if I change the sign of both of them, that would be if I change the sign of both of them, that would be -3, 1. -3, I'm sorry, -3, -1. So that would be a 90-degree rotation back to here. I'm going to get a little bit confused there. All right, so G ends up here. So it's a 90-degree rotation from here to here. All right, so now what if you want to go to the second, I'm sorry, this is the 4th quadrant. So in this quadrant, the x value is positive and the y value is negative. So I'm going to switch the order. So I'm going to change the order to 1, 3, but I want to end up down here. So this is going to become a negative 3. So now I'm going to go 1 unit out this way and a negative 3 units this way. So it's going to end up right here. So it's a 90-degree rotation to end up right there. So you switch the order and change the sign of one of them. So it's 90 degrees to go from here to here. It's 90 degrees swinging this way. And the last one, switch the order, negative 3, 1, but now I want to end up in quadrant number 3. Well, that's a negative value and a negative value. So it's going to be negative 3, negative 1. So it's going to end up right there. Negative 3, negative 1. So it's a 90-degree rotation swinging this way. And to get back to this original G, change the order. So negative 1, negative 3. But you want to go positive. You want it to be a positive value. You want to end up in this second quadrant. So it's going to be negative 1, positive 3. So negative 1, you guys change the sign of that negative 3 to positive 3. So it's negative 1, positive 3, and you end up back here. So a right angle. And so I would suggest that you do the same thing with I and the same thing with H. Just practice moving each of those points from one quadrant to the next at a 90-degree angle. If you connect the points, you're always going to get a square. You have to, because you're moving 90 degrees. You're doing 90-degree rotations. All right. This next problem, you're going to, through a sequence of transformations, how do you move A to B? So you're going to slide A over here. And so this point is going to move over and match this point, and then you're going to rotate this 60 degrees. So it's going to land right on top of B. So you slide A over here, and you rotate this 60 degrees. I'm going to show you that rotation. All right, so you can put a protractor right on top if you want. And that's a 60-degree rotation going from this side right here and rotating this purple trapezoid to this blue trapezoid. So this rotates 60 degrees, goes from this point to this point. Now you can do that whole rotation and do that whole movement as a single rotation if you can find the center of rotation. And it's a little bit hard to do, but you should be getting used to that. So you connect the corresponding points, find the midpoint, and draw a line that's perpendicular to that. So connect the corresponding points, find the midpoint, and connect a line that's perpendicular. Draw a line that's perpendicular. You do that 4 times for each of the corresponding points, and they're all going to intersect at the center of rotation. So this is a 60-degree rotation moving A to B without a sequence of transformations, just a single rotation. So there's the 60 degrees, and that's moving A to B. And finally, the last problem, you can slide or reflect P from this position over to this position. So when you think of reflection, you're going to move at a perpendicular, in a perpendicular direction to the line of reflection. So that's at a right angle. So this point is going to move this way at a right angle to the line of reflection, and equal distance on the other side. This point is going to move to the right, right angle to the line of reflection, and equal distance on the other side. This point the same, this point the same, the same, and the same. So I'm drawing those lines at a right angle to the line of reflection, so they are perpendicular. So I'm going to move along these lines. They're going to move an equal distance to the other side of the line of reflection. So the pink are these first points. So this is a half of a unit and a half of a unit on the other side. 1 unit and a half, and 1 unit. 1 unit and a half and a half and 1 unit. And the back side I did in blue. So this is 2 units and a half. So there's the half and 2 units. 3 units. 1, 2, 3 and a half and 3 units. And then 2 units. 1, 2 and a half and 2 units. So you place points at the end of the arrows, connect them, and you get the reflected image. This is a hexagon. There's 6 sides. It's a hexagon. And so this is a reflected image across the y-axis, or across L. And if you color them in, I actually turn this. This is a reflection of this image. So I slid this image up to the top. So it's right here. And I actually twisted it a little bit, rotated a little bit, and then did a reflection of it. And I ended up with this image down here, colored it in, and you just get kind of what I think is kind of a neat figure. There's kind of an illusion here. This looks like it goes along the bottom, then up the back, or it looks like it comes out the front and goes up the front, and it actually twists. In my mind, as I look at it, it twists back and forth. This one does the same thing, but actually not as much. This one a little bit easier for me to see the switch. Anyway, you play around with the reflections, you do some coloring in, and you get neat designs. I rotated it around just to see what it would look like. And back to the beginning. Alright, so problems on translations, reflections, and rotation.